Good evening. My name is Anthony Agansi, and this is my System Dynamic and Control Project 2 Electric Power Steering versus Hydraulic Power Steering Analysis. So, just for some background information, um, the power steering system that we see in vehicles, in most vehicles today, weren't available to the mass market until 1951 when Chrysler introduced it for commercial purchase in their Chrysler Imperial. This was a hydraulic power steering system designed to aid in steering. So before this, the big trucks that we see, the big vehicles in the 40s and 30s, they were hard to steer, to say the least. They required a lot of physical strain. They required you to actually put your back into it. So this hydraulic power steering system is basically there to help ease the load. This system uses a rotor vane pump powered by the vehicle's engine mechanically to basically multiply the force that you're applying to the steering wheel and send it directly to the wheel. So this hydraulic system includes a power steering pump, high pressure line, and a belt, which is connected directly to the engine. So the engine, the actual vehicle engine, is powering the power steering system. So with my project, I'm going to compare two types of power steering systems. The previously mentioned hydraulic steering system and the electric powered assist system, which was first introduced by Suzuki in 1988, or some people shorten it up to call it the E-Pass. So the E-Pass is same concept. It is used to help with steering, but instead of using the belt and the pump and that whole, clunky system, it just has one simple electric motor attached to the steering rack, and it's basically with wires connected to it. It's basically computer controlled, and it utilizes sensors to help with steering. The inputs and feedback through the steering wheel to the wheels will be analyzed in this research project, and the factors that affect each system will be analyzed. So this is the E-Pass, or the electric power assisted steering. You can see the electric motor attached to the front end steering rack. It's a very simple, clean design. So in the project, I will be using parameters such as torque feedback, path accuracy, and discernible play. So what ignited this topic of discussion was basically many car enthusiasts or people who are really into cars, actually some of them do not agree with the use of electric power steering. They feel that the more refined hydraulic systems give better steering feedback, and they're actually connected to the ground because there's a mechanical connection. and because of this, they feel that they're just simply better to drive. So with my project, I'm going to try and see which one is really the best through different categories. Some pros with the electric power steering or the E-Pass is it's lighter, so there's less going on, so there's going to be less weight. There's less heat because there's not a belt that's constantly being moved. This means there's less friction, and it's also smarter since it is computer controlled. So the E-Pass can detect your speed and apply the appropriate resistance needed to turn. And it will. One of the main concerns is, will it work if the car battery dies? It will continue to work. And with the lighter weight also means better fuel economy. So most people would think, okay, this system is clearly better than the hydraulic, the older hydraulic system. But sometimes that sometimes that's true, and sometimes it isn't. And so this is what will be discussed in my project for MENG 4312, section 63. Thank you.